Good morning, or afternoon, or midnight, or whatever. I am here to teach you all about Algebra 2, Section 9.1, right triangle trig. We're going to start Chapter 9 today, after spring break. Hope spring break was restful and not too stressful for you. Happy April. So we're going to do one section every week. Normally I do one section every time I see you in class. So we're going to do one section every week until we get to the time when we have our reunion, which will be fun. I learned new things. For instance, I learned how to crop my screen. So that way this little line right here, I can actually be looking over here where I'm writing so it doesn't confuse you like last time maybe did a little bit when I taught you 7.1. Just as a reminder, that was Chapter 7. We're all done. I kind of want to try to test you on it, but I don't want to try to test you remotely, so I'm just going to assume you know everything. Sound good? Sounds good to me. But here's the fun thing about not having our class. This is page 52, or 53, but it is our Chapter 9 review page. This is where the pre-post goes. And I don't have a tab for you. Maybe I'll try to like mail it home or something. That would be weird. That'd be way too many stamps for one little piece of paper. But it makes me kind of sad to skip a whole page and not have a tab for it. We're just gonna have to deal with it. So this is 54, and we're doing section 9.1, which is right triangle trig, which is kind of exciting for me because, number one, you already know half of this stuff, and the other half is just the other stuff flipped over. So it's not really that big of a deal, because in geometry, you learned, actually in a lot of math, but most recently last year, so you learned this thing called SohCahToa. Do you remember that? In class, a lot of people tell me that they totally remember, but not what it means at all. So let me just remind you. So means that sine of some angle. This is theta. Say hi, theta. Theta's like a 0 with a line through it, or a dude wearing a baseball hat is what I think of. So means that sine is opposite over hypotenuse. Now, hypotenuse is where the hippo sits, which is why I have hippo stamps with the hippo on it. Make sense? Sine is that cosine of an angle is adjacent over hypotenuse. I can't write right now. And then tangent of that same angle would be opposite over adjacent. And that's what SohCahToa stands for. If I had a cool highlighty thing that would pop up right now, that'd be great. Sine is opposite over hypotenuse. Sine, opposite over hypotenuse. Cosine is adjacent over hypotenuse. Cosine, adjacent hypotenuse. And then Toa, T-O-A. So it's all the first letters, and that's our little mnemonic for remembering what's what. So today I get to teach you about the other three. Because SohCahToa all can be flipped over, but we don't have a word for the ho, for the H over A. So what we're going to do is we're going to call this, we're going to say cosecant. Cosecant of an angle is the buddy for sine. They are BFFs. And they can't see each other right now either. It is hypotenuse over opposite. It's the flipped over version of sine. It's the exact opposite. They go together. I always tell my upper level kids that every C needs an S. Sorry, every letter needs a C. So sine and cosecant go together, even though you'd really like cosine and cosecant to go together because they sound really nice, but opposites attract. Everybody needs a BFF that's opposites. Likewise, the opposite of cosine is a secant. That's secant. Sec. By the way, we don't say things like sin, cos, and tan. It hurts me inside. Luckily, you can say that to yourself at home all you want. But if I hear you say that in any of my office hours, I'm blocking you. I won't really. But in my old classes, I used to throw markers at kids who said it, and then I ended up breaking a marker and hurting some kids, so I stopped doing that. But it hurts me inside enough that I still want to. So secant and cosine go together is hypotenuse over adjacent. And the very last one, again, every letter needs a C. Tangent gets a cotangent. And just like sine, we don't say cot. We say cotangent. We say its whole name. We don't use these Algebra 1 level nicknames. We call it its adjacent over opposite. So, if I may, ChoShaCao. We don't usually say things like that, but that would be the idea. ChoShaCao. Anyways, so those are the other three, and I'm going to say their names again. Cosecant, secant, and cotangent. Okay. So, for instance, actually, let me write those down because I feel like I just need to. Cosecant, secant, and cotangent. Let's make like a little speech bubble. And again, these are paired up. So sine is BFFs with cosecant, cosine's BFFs with secant, and tangent and cotangent go together too. They're like this. They're tight. Okay, sounds good. Okay, so let's use this in context. That was information. That was your little FYI. This is your reminder. I should probably draw you a triangle so you know what the heck I'm talking about. This, by the way, only works for right triangles. That's why it's called right triangle trig. These things don't work for other triangles, so it has to be a right triangle. So let's say that my theta is right here. The one opposite from this is opposite. The longest one is the hypotenuse. That's where the hippo sits. And then the one that's left is adjacent. It's the one that, it's the one that if there was a dude standing here, he could slap it, but it's not the longest one. That's the adjacent one. Now, this whole thing gets rotated if I move the angle to the other side. Hypotenuse is always the longest one, but then opposite would be on the other side. So we got to be careful with that. It's fine. We'll figure it out. Let me move this up a little bit. My examples are over here too. So for example, in an acute right triangle, all right triangles are acute. We know that sine of an angle is 4/7. We want to find secant of that angle. Now, again, it's really tempting to just flip that one over, but remember that sine doesn't go with secant. Sine goes with cosecant. So to find secant, we need to be able to find the hypotenuse over the adjacent side. Okay. So far I have a triangle. Let me just draw a triangle. By the way, in Germany, they did a survey, and I think, it was Germany. They found that people only thought that triangles were triangles if they were straight up or had a flat bottom. And they were like, what? All triangles are just three-sided shapes. I don't get it. And then they looked at all the textbooks, and every textbook, the triangle had a flat bottom. So now they started doing it so that way they're any which way. You'll see that too. But we're more comfortable in general with the triangles like this. It doesn't matter what angle I call theta, so let me call this one theta, which means that dude standing here, across from theta is opposite, longest is hypotenuse, and the other side is adjacent. So we have our three angles, or three sides. Because it's sine, we know sine of an angle is opposite over hypotenuse. And we know sine of this angle is 4/7. So I know right away that the opposite side from theta is 4, and the hypotenuse length is 7. And then I also know that secant theta is going to be hypotenuse over adjacent, because it's a flipped over version of cosine. So I already know that the hypotenuse is 7, but I don't know the adjacent side. Now there's a thing that you've learned since 6th grade. And I know this because every adult yells it at me when they find out that I teach math. Let me give you just a second to see if you can figure out what it is. I think you got it. I have to assume because I'm not in class right now and I can't hear you yell at me. But there's this thing called the Pythagorean Theorem. Which is a squared plus b squared equals c squared. And c, in this case, is always the hypotenuse. It's the longest side. So what we know is that 4 squared plus x, I don't know the adjacent side, equals 7 squared. And then I do that math real quick. 4 squared is 16. 7 squared is 49. Ooh, I have way more work to do. I should be, I need 2 pages for this. If I subtract the 16, I get that x squared equals, I know I'm going too fast. Pause the video, it's fine. 33. 33 is not a nice square root. If it was 36, that'd be pretty nice, but 33 is not a nice square root. So all we say is that x equals the square root of 33. Or a nicer number if our calculator tells us that that's a nicer number, but we're going to leave it alone. So because of that, I know that secant theta is going to be 7 over the square root of 33. Which, I don't know if you remember this, but we can't have a square root on the bottom. So what we do is we're going to take the root 33, multiply it to the top and bottom. But that's a really complicated way of just saying that we're going to move the 33 to the top and make it just 7 root 33 over 33. That's the same thing. I'm going to call it good there. If you want to know more, come to office hours. Because those are the thing that I do that nobody showed up for on Monday. I totally get it, but also I was a little sad. We got a lot of work done though. Okay. That's that. Okay. I'm also going to show you, I'm really not going to have enough room for this. It'll be fine. We're going to solve the triangle. And let me just, I'll flip the triangle over because I spent so much time talking about Germany. So what we know about this triangle, do we know this, is that this side's 28 degrees and this side is 15 of something. Now normally what we do when we have triangles, I don't have enough room, is that we call, this is a right triangle, we call the angle across from a side, the angle's capitalized and the side is lowercase, but they're the same letter. So that's big A, little a, big B, little b, and big C and little c. Now, big C's look like little c's, but it's fine. So what it means by solve the triangle, it means find all the parts that are missing. So basically what we know is we already know angle A and side B. I just need to find the rest. So we can do that. So here's what we're going to do. I'm going to find angle B using one of those things that we learned back in geometry. Do you remember what it is? All triangles add up to what number? You either said 180 or 360 if I've been doing this long enough. It's 180. All the triangles make a straight line if you rip the corners off and rearrange them. So what I'm going to do is I'm going to say 90 plus 28 plus b equals 180. I'm going to do that math really quick. If I subtract 90, I get 28 plus b equals 90. And if I subtract 28, I'm doing this by my memory, 62. Yeah. So I know the angle B is 62 degrees. Cool. I also already know the angle C is 90 because even if it doesn't say it, It's a 90-degree angle right there. So I'm done with the angles. Yes. I have to find the sides though. So here's what I'm going to do. I found all the angles. I'm going to use one of the angles and one of the sides using SohCahToa or ChoShaCao, the other ones, to figure out another side. And then I'll use Pythagorean Theorem after that. So what I know is that sine, I like sine a lot. Ooh, but it doesn't, oh yeah. I know sine of this angle that I found of 62 degrees equals the side opposite from B, which is little b, 15, over the hypotenuse, which is C. I know that to be true. Here's the cool thing though. I could also have done cosine of 28 degrees equals 15 over C. Or I could have done tangent of 28 degrees equals A over 15. Or I could have done tangent of 62 degrees equals 15 over A. Or I could have gone super crazy and gone into cosine and stuff. But I digress. Here's what I do need though, and I need to pull this up while I'm talking to you, is I need a calculator. Now, I did not grab a calculator from school like I should have. So, I'm going to show you what you can do in the same situation that I'm in. Perfect. I'm glad I set this up last time. Desmos.com. Normally we go to student.desmos.com, but in this case, we're just going to go to desmos.com because down here, I have a scientific calculator. Now, I really wish this looked like our normal calculators, but do you see how on here it says sine, cosine, and tangent? Hope you do. So let's just, for fun, let's say I had like 45 degrees and I wanted to have the sine of that. Oops. This is what an important thing to find out. In your iPhones, you type in the number and then you type in the function that you want it to do. In the yellow calculators and here, we're going to do the function that we want it to do, and then we'll do the degrees. Then you see how it says 0.707? Okay, that's root 2 over 2. It's the same thing. We're good. Make sure that it's in degrees. This is very important. Very soon we're going to find out what radians are and change it all to radians, but right now we're just going to leave it in degrees. Now, I don't really want sine of 45. No. What I really want is sine of 62. So I find out that sine of 62 is 0.882. Okay, so then I go back to my notebook, and I know now that sine of 62 is 0.882 equals 15 over C. Now, you don't like fractions, but this is just basic baby fractions. I'm going to multiply both sides by C and divide both sides by 0.882. But in reality, what I'm going to do is I'm just going to switch these two things. That's my math teacher secret. You can do that. Because all you're doing is you're multiplying by C and then dividing by 0.882. So C ends up on this side, and the 0.882 ends up over here. Now, if this whole fraction was flipped upside down, I would be multiplying by 15 instead. Okay, so careful. Let me, after this, once we're done, I'm going to show you one version of this where I do it with the fraction flipped over so you can see what I mean, because I think it's very important, but you'll know everything that you need to know right now. All right, let's go back to the calculator. I want to do this. I wonder if I can manipulate this. I'm going to do 15 divided by, can I click on this? No. 0.883. Let's round to 3 because it's 0.8829. So I get 16.987, which will round to about 17, which is fine. I think this shows me a converter that converts it to a decimal, or a fraction. That's so cool. Okay, so I'm rounding this because it's a couple extra decimals, so I have to round it up to 17.0. This is where I'm talking about how I didn't have any room. Maybe I should rearrange this next year, but it's fine. Okay, so this is side C, so I don't put the degrees on it. Okay, so far I know all the angles. I know little c, I know little b, I just need little a. I could do another trig function, but why not just use Pythagorean Theorem? So I can do a squared plus 15 squared equals 17 squared. Pretty cool. 15 squared is 225. Oops, that should be a plus. I didn't grab the white out either. My life. I don't know, especially off the top of my head, what 17 squared is. Maybe I should. 289? Of course it's 289. Why didn't I think of that? It's fine. So if I subtract 225, I get 64. Y'all, that's a nice number. A equals 8. Well, I didn't actually expect that. Okay. I do need to show you one more thing before I set you free to your homework, because on your homework I ask you so nicely to use a calculator to find things like cosecant. So here's what we do. This calculator doesn't have a cosecant. Maybe it does later. Nope, sure doesn't. So what we're going to do is, if I wanted cosecant of 32 degrees, let's say, what I would do is I would say it's going to be 1 over sine of 32 degrees. And that'll get me my cosecant, CSC. So remember how they're buddies? What you would do is you would say it's 1 over the buddy function, and that'll give you it as a decimal. Okay. You know everything that you need to know. What I'm going to do is I'm going to set you free. You can stop this video here. You're done. I'm going to show you your homework, but this is also on the Big Ideas, and it's on the Google Classroom. So this stuff's all on the Big Ideas math. I also set it up so you can check your answers at least once. And one of the 33 or 34, you can actually ask for help. I think it's 33. The 27 through 32 they assume you can do because it's just using a calculator. Desmos.com, and then click on that little scientific calculator, or do whatever math you want to do in the calculator. At this point, who really cares? And the yellow ones, it's a green button, and then it's sine, cosine, and tangent will be the opposites. Pretty cool. But your other option, if you want, because we do this in class, is you can try this one instead. It's a little harder because it's a couple triangles and you kind of have to figure out what's going on, but you can totally do it. You have all the information, and I believe in you. Just remember that 90 degrees is the corner there, so you can subtract stuff and figure it out from there. Pretty cool. Pretty easy. So that's an option for you, but I would recommend doing these on the Big Ideas math, and then I have to set up some sort of system because I keep getting emails from kids doing their homework, and then I know I'm going to lose them because they're emails. They get buried so quickly. Okay, so you can stop it here, you can pause it, I'll say goodbye, but I'm going to go back and I'm going to do some more examples. That way you have a couple more options if you get stuck, because I can't show you that in person unless you come to office hours. So, you know. Okay, pause, do your homework. Okay, now that they're gone, I'm just kidding. Okay, let me show you some things that people get, or let me clarify some things I just said, and then I'm going to show you some things that people get stuck on. So if I wanted to calculate CSC of 32 degrees in the calculator, what I would do is I would say it's 1 over sine of 32 degrees, because they're buddies. Or if I wanted secant of 47 degrees, I would do 1 over cosine of 47 degrees. See how that kind of works? Same thing with cotangent. If I wanted cotangent of 72 degrees, I would do 1 over tangent of 72 degrees. That's what I would do in the calculator, and that's how I would figure out those answers. I can't sit for so long. All right, let me talk about what I was talking about earlier with that one triangle. So this one. So what I did here was I set up for sine, but let's say I have the exact same triangle. I know 15 and I know 28. And let's say I wanted to find this one. Let's just say I have this more simplified version of the same triangle. To find this one with only these two things, I would need to use tangent, because tangent is the only one that is opposite and adjacent. Sine needs to know the hypotenuse to work, or needs to know the opposite, one or the other, and cosine, same thing, so tangent. So I would use tangent of 28 degrees equals x over 15. And then I would go back to my internet. Oh, I closed it. Did I close it? No. So I go back to my internet and I would say, okay, let's try tangent of 28 degrees. That's 0.532. I like to keep it to 3 decimals. If I get a little lazier than that, my answer gets to be super off, and I don't like that. So what did I say? 0.5. What did I just say? 0.532. I have so many windows open. So 0.532 equals x over 15. Now, I'm going to multiply both sides by 15 because my x is on top. So it's x divided by, I'm going to multiply by 15. If x was on the bottom, that's when I would do the switchy thing. So I get x equals whatever 15 times 0.532 is. Some of your geometry teachers taught you to multiply first and then do the math. I don't care. It's the same. All right, let's switch back. So I'm going to do that times 15. So I get 7.97, which, did you notice, rounds to 8, which is the number that we got. It was 7.97, or x, ooh, I should have done that earlier, x equals about 8, which is what we had in the first place. I said that this side over here, side A, equaled 8 when I did it the other direction. So the kind of cool thing about SohCahToa and this kind of trig is that you can do it any different ways and you'll still get the same answer. Okay. Do I have something open? Hold on. Do you have the time? Yeah. Perfect. Do you want to do one together? I'll start it and then you can pause and then you can come back and try it. Let's do that. Next page. Let's try this triangle right here. Let's try, I'm going to call it ABC. It doesn't matter. And then what I'm going to tell you is that angle B is 16 degrees. And I'll tell you that side B is 14. Remember that the sides are across from the angles. So this is little a, this is little b, this is little c. We also sometimes, sure I'll cricket. We also sometimes will do thetas and alphas and betas and stuff, but it's the same. Okay, so pause here, try to do the math on your own, come back and just see if we get the same answer. Once again, there's a multitude of ways that we can do this problem, but it doesn't hurt, right? It doesn't hurt to try to do it the same. Or, sorry, it doesn't hurt to do it different ways, but we should get the same end answer. That's called an open middle problem. So you pause it here, and then come back when you're done, and I'll just keep going. Catch up to me. Okay. I want to find this other angle first. So what I'm going to do is I know that 90 plus 16 plus angle A is 180, because that's what a total triangle is. If I subtract the 90, I get 16 plus A equals 90. To be honest, this is probably the step that I usually skip to, because I don't want to deal with the whole subtracting 90 every time. So I usually just start here. And then if I subtract 16, I get A equals 74. Yeah, mental math, you guys. I got it. My phone's charging somewhere, so I can't even use it as my backup calculator. It's fine. So I got angle A. And because it's an angle I want to remember that, so I'm going to put the degrees there. So I'm already halfway there. All I need are sides A and side C. Doesn't matter which one I start with. I'll get the same answer both ways. Maybe I'll start with side A this time. Maybe I'll start with side A. Or let's see, what happened? I haven't done cosine. So let me do cosine really quick. So I'm going to use cosine with this part of the triangle because cosine of 74 will equal 14 over c. I'm going to use this one, but let me just list out the options that you could do. You could have done sine 16 equals 14 over c. You could have done tangent 16 equals 14 over a. You could have done tangent of 74 equals a over 14. Or this one. Those are your 4 real options. You also could totally use cotangent or secant or cosecant, but those usually include coming back to sine, cosine, and tangent, so they're not as useful right now. They'll be useful later, but not right now. Okay, so these are your options that you could have done, but I'm going to use this one just to show you what cosine looks like. It's the same. It's the same math. All right, I got to go back to my calculator. So I'm going to do cosine of 74 degrees, has to be in degrees, is 0.276. Great. So I have that number now, and that equals 14 over c. And then once again, I can swap these two. So I get c equals 14 over 0.276. Back to my calculator. 14, oops. Maybe I can just put it in front here. 14 divided by, oh, I didn't do it. I have to rewrite that. Oh, 0.276. That's why I write things down, huh? Sure. I get 50.7 when I do that math. That's not really close enough to round up to 51, but, you know, I could leave it that way. It's fine. All right. So that's my value for little c, not the angle, the side. Those are my options. You could have done any of those, and if you were finding c, you should get the same. If you're finding a, we'll have to see what you should get when you find a. We'll compare it notes. And then I use my Pythagorean theorem, because a squared plus 14 squared is going to equal 50.7 squared. That feels really big. Oh, it is, because it's 16 degrees. We're fine. My triangle's just super skinny. Once again, I should know these things. 14 squared is 196. So a squared plus 196 equals, and then I go, okay, what about clear? 50.7 squared. I'm at 2,570.49. And then I subtract the 196, which I'm doing on my notepad. I wish I could add. Probably can do that real quick. That's fine. So then I subtract. Shoot, man. Sometimes in calculators you can say like the previous answer. Oh, there it is. I found it. Minus 196. So then I get a squared equals 2,374.49. And then I square root both sides. So then I go square root of the answer. There we go. So I get that a was 48.7. Is that what you got when you did the other way? We'll see. So those are my two sides that I was looking for. So now I have the 3 angles and the 3 sides. I've solved the triangle. Good job. I'm proud of you. Okay. If you have any other questions, pretty please come to my office hours. Monday 3 to 4, Thursday 11 to noon, or Friday from 2 to 3. I spread them out so that way you could figure out what works best for you. And I'm looking forward to seeing what worked best for you. So I'm going to go back to the homework slide. and I'm going to peace out, and I hopefully will see you today, Thursday, or Friday. Have a great day. Okay, bye.